All right, thank you for having me. I hope Harike was saying nice things about me on the intro. I'm excited to be here. Great to see such a great turnout here, at Serverless Days and seeing all the energy about serverless here in Japan. I've been working with the serverless community for nine years now, and I love the energy around it. I love the excitement and just what we can build with it. When I talk about serverless, I think it really kicked off with this slide at AWS reInvent in 2014. Werner Vogels went up there and announced AWS Lambda, this new computing service where you just upload your zip file and on-demand compute there. I was actually sitting in the audience this day, and a lot of people say, "Hey, when I saw this slide, I knew this was like the next big thing. I thought it was going to be so big." I admit that I did not. I did not know it was going to be this big. I confess that, and part of the reason was it only had two events that you could hook up at the beginning, right? You could hook up S3 bucket notifications, which is really useful. I actually had a use case for that right away. And then the other event source was DynamoDB streams, which like I love Dynamo now. I do a ton with Dynamo. I think it's really great, but I had not used and probably had barely heard of Dynamo in 2014. So I didn't have a use case for it. So yeah, I did not know how big this is going to be, but I'm so grateful for what it's become, and I've loved working with it over the last 9 years. Today, I'm going to be talking about serverless now and then, and just looking back over the last 8 or 9 years, working with Lambda and understanding what I've learned, and then some patterns I'm seeing now. So, just in terms of what we're going to cover today, first two things I want to talk about is just like what early serverless was like, how we sort of got on that road to serverless, and some things we learned there, as well as just like looking back. What is the key to serverless and these different serverless services? What makes a service serverless or not? And then some trends I'm seeing that are kind of interesting. I think the rise of some non-AWS services within the serverless world, as well as just like some patterns for successful serverless teams, working with a lot of teams over the last couple of years. What patterns are they having there? Who am I? I'm Alex Debrie. I'm an AWS data hero. I do a lot with DynamoDB and serverless architectures now. I used to work for Serverless Inc., which makes the serverless framework. So if you ever use that, I worked with that team for 2.5 years and really just love the community and love working with it. I love AWS. I love serverless. I think it's just a great ecosystem to be a part of. All right, so I want to start with serverless then. And we'll start with sort of paving the road to serverless, right? Because I see serverless as this sort of evolution or maybe even culmination of compute and what it looks like, right? And if we think about what that road was like on the way to serverless, before 2006, you probably had, everyone had their compute in data centers, maybe that they ran, maybe colo, something like that. But you very much knew sort of the physicalness of your servers. Maybe you were plugging them in yourselves and racking them, or at least you knew where they were. Things like that. And then EC2 comes out in 2006 and changes that, right? Now you don't know where those data centers are. You don't know where your server is within that data center, but you still have to think about your server quite a bit with that. You have to configure CPUs and RAM and disk space and network and all that sort of stuff. So there's still some aspects of that there. And then finally in 14, with the release of Lambda, that's changing even more. We're even less aware of the physical nature of our servers and where they are. We don't know their IP address. We don't know any of that stuff. They could be moving all over the place there. And I was sort of fortunate, I actually just started programming right before Lambda, maybe 2 years before that. So I didn't even have some of this historical background there in those other things. But I think as people move from data centers to EC2, they had to evolve their practices. As they moved from EC2 into Lambda, they had to evolve their practices. And as I'm sort of looking back on that, I think there was one thing that really helped that transition from EC2 to Lambda, and especially for me, like picking up Lambda and how it was, and that was Heroku. Anybody here use Heroku back when it was a thing? Yeah. I love Heroku. I thought it was so awesome. This was the first way I deployed applications, and not only was Heroku easy to use and great, but they had this idea of the 12-factor app, right? Which was like this very opinionated manifesto on how you should be building applications. And I think a lot of it is still relevant today. recommend go look this up and look at these 12 different factors. And a lot of these, I think, pave the way for serverless architectures and what we're doing there. So just looking at a few of these, it talks about making sure your code base is tracked in version control, and making sure you have that in Git or something like that, and then deploying from there. Talks about backing services, right? Things like your database, your blob storage, all that stuff, treating it as sort of attached resources. And then your compute is a stateless process, and maybe you split it up by the different types of process it does. Maybe you have your web process and your worker process, and they're sort of different. And then if you need more of those as you scale up the number of instances of a single process that you have, right? So more web nodes, more worker nodes. Also talks about disposability, right? And talking about fast startup and graceful shutdown, which those of us in the Lambda world are really familiar with, right? Cold starts and just thinking about what happens if our instance goes away. And then finally, dev prod parity, making sure you have multiple different environments, development, staging, production, making those as similar as possible. So as you're sort of developing, you have an idea, you have confidence that this is going to work as you sort of move through to production. So just thinking about the Heroku Lambda pipeline and the way Heroku sort of set the foundation and Lambda even expanded on it. Heroku talked a lot about version control and making sure you're deploying from version control. And I think Lambda serverless really expanded that to say, hey, that applies to your infrastructure too, making sure you're having infrastructure as code, making sure that's tracked in your version control and all that. Another thing it emphasizes having these high fidelity replica environments where you can, test in an environment that's very similar to your production environment. I think Lambda, you can take that even further and say, do that for every single change. So I know some teams that every time they make a pull request, they sprint up a brand new environment and isolate and test just against that. Heroku taught us your compute should be stateless. It should be able to go away and just spin up new ones and scale that up and down very easily. And also isolating that by process, by different types of work you're doing. We do that a lot with Lambda too, right? We have different functions for different things, have some nice isolation there, but we expand that even further by isolating by requests. So each Lambda is only handling one request at a time, and you have that nice isolation. And then finally, state is added via dependency injection, right? You have this stateless compute, but you still need state in your application somewhere. So you basically inject it into your application via environment variables. You give it connection strings that it can then reach out to and handle that way. And we still see that pattern today. And with Lambda, we really want to see, fully managed services for our state. So those are the 12 factors I recommend looking up, as you're sort of thinking about where Lambda came from. I think that was very influential in how we develop with Lambda. So let's move on and talk about the key to serverless, because there's a lot of debate about what is serverless and things like that. And if we go and look back at those principles I just talked about, and especially that last one, right? I think the Lambda aspect being serverless, that's very obvious, the stateless compute, but for stateful services, what makes something serverless, right? And the nice thing about the AWS ecosystem is Lambda came out in 2014, but right when that happened, there were a bunch of services that fit really well in that serverless world that had been created before that, right? That we didn't even know were serverless until Lambda really showed it to us, right? So we're talking about SQS, the first AWS service back in 2014, 10 years old by the time Lambda comes out. We have S3, of course, for, image storage, file storage, blob storage of any kind, came out in 2006. And SNS, for PubSub in 2010. So these are all critical services. But the one I think that is most interesting, and maybe it's just because I love Dynamo, is DynamoDB, right? So DynamoDB came out in 2012, but it was very quickly adopted within the serverless ecosystem, which I think is kind of weird when we look back on it, because there are a lot of reasons Dynamo wouldn't be popular in the serverless world, right? I mean, if you look at it, it was built for truly enormous scale. People like Amazon.com or SmugMug, Snapchat now, Sony, all these enormous use cases, they needed DynamoDB. But I would say early serverless users probably didn't have that type of scale. They were smaller, scrappy startups trying to build something quickly, and it wasn't the scale of Dynamo that was interesting to them. And then also Dynamo has this weird restrictive data model. If you're coming from a relational database world, it's very different than working with Dynamo as compared to that relational database. And some people might say, hey, it's because Dynamo's on-demand billing model, but that didn't even come till 2018. So that's 4 years after Lambda launched. So it wasn't those things that made Dynamo popular. What did make Dynamo popular within serverless? Well, it was a couple other features, operational type features, where you didn't need a VPC with DynamoDB. So traditional architectures, EC2, Amazon RDS, all that stuff, you put it in a VPC, you had this isolated networking that way to handle that. That was hard with Lambda. When Lambda came out, you couldn't put it in a VPC. Even when you could, there were some cold start issues for a while where it'd be 5, 10, 15 seconds for cold starts. So it made VPCs a non-starter for a lot of folks, and Dynamo didn't require a VPC. There are also no connection limits in DynamoDB. So relational databases, they came from this world of more static compute, and they didn't anticipate having thousands of open connections to them, and they couldn't really handle that sort of thing. But with Lambda, you could easily spin up hundreds or thousands of connections very quickly and overwhelm your relational database. Didn't have that issue with DynamoDB. DynamoDB was very infrastructure as code friendly and fast to provision, right? So you could provision it all with infrastructure as code. It would be ready quickly. So if you want to have those replica environments, it was very nice. It worked well with Dynamo and serverless. There are no maintenance windows with DynamoDB. This is one of the best things about it. To do a minor version upgrade, major version upgrade, there aren't those upgrades happening. Dynamo is updating all the time, but you're not explicitly choosing into that. And likewise, there are almost no operations with Dynamo. You don't have to worry about running out of disk space or upgrading the RAM and CPU or the instance type, any of that stuff with DynamoDB. So for all these reasons, Dynamo was very popular in the serverless world. And I used to say, hey, the reason Dynamo is popular with serverless is because it's fully managed, right? All those things I thought fell into the fully managed bucket. But I think that term is not quite clear enough, because when I searched Amazon RDS recently, and this came up in Google, right? It says it's a fully managed relational database. So it's using that fully managed terminology there. But if we look at RDS and serverless and some of those same things we talked about with DynamoDB, RDS has a VPC requirement. You have to be in a VPC generally to use RDS, right? RDS has connection limits. Postgres, MySQL, SQL Server, they're going to have connection limits, and you'll need to deal with that from your Lambda function. You can provision RDS with infrastructure as code, but it's not quite as fast to provision as a DynamoDB table, because they have to go find a server somewhere, boot up the machine image, configure it, all those things. There are maintenance windows in RDS as you move from up minor versions or major versions there. And there are just more operations in RDS. You probably need a DBA or someone that knows relational databases decently well to help operate that, right? So fully managed probably isn't the right term to discuss, whether something is serverless or not, especially something stateful. So what is the key to something serverless? And I think it's multi-tenancy, right? Services that are multi-tenant are inherently going to be more serverless, especially if you're talking about those stateful services. That's where that's going to happen. And I did a talk at reInvent last year on DynamoDB, and my co-presenter, he works on the DynamoDB team, and he presented, this is the DynamoDB architecture. There won't be a quiz later on this, but just looking at it, like there's a lot of different components in it, right? And when you're working with DynamoDB, all the customers within a region are basically working on the same shared infrastructure for that. So you can see there's a shared load balancer layer. There's shared request routers, which are handling your requests and reaching out to the different storage nodes to handle them. And then they have the different storage nodes behind them that are actually storing your data. And your data is going to be split across lots of different storage nodes. It's going to be, on the same nodes as other customers' storage nodes and all that stuff. So it's not just a single instance that is dedicated to your database. It's this large system that's working across thousands of instances that's able to provide you this truly serverless experience. So I think that multi-tenancy is the key. And if we look back at the other stateful services that we know and love in serverless services, those are all multi-tenant as well, right? SQS, they are not sort of spinning, they're not slicing off a server somewhere and dedicating that for your queue processing. You're part of a shared region-wide service in SQS, with S3, with SNS, all that stuff. And I think multi-tenancy is the key to these serverless services. Kwaja Shams, he's back there. He'll talk later. He really put me on to, sort of the importance of multi-tenancy. He wrote this post, if you want to go check it out, The Dark Art of Multi-Tenancy. I think there have been some good posts that have come out recently around multi-tenancy. This is one. Another one is from the PingCAC folks, Ed Huang, who's a CTO at PingCAC. I think Max is talking later, but Ed had a really good series of posts on taking TIDB serverless and what that looks like. And his last one was around multi-tenancy, so check that out. And then Andy Warfield, who works at AWS, he works on S3 at AWS and talked about multi-tenancy within S3, what that looks like and what the benefits of that are, and how they're able to sort of provide a serverless service there. So multi-tenancy is the key, I think, to serverless. And if we look at our sort of Heroku to Lambda pipeline, one thing we'd add there is just prefer multi-tenant services when possible. Sometimes there are trade-offs there, but I think multi-tenant services are often going to fit better in your serverless architectures. Let the translators catch up. If I was going too quick, slow down. Sorry, I'm going too quickly. All right. All right, so let's talk about serverless now. That's some serverless then stuff. What sort of trends am I seeing now in the serverless world? And I think recently, just a little bit, you're seeing the rise of non-AWS services within serverless stacks, which I think is a new development. And I love AWS. I think they do a lot of great work. I still prefer them in almost all cases, but early serverless stacks were especially AWS heavy, right? They're really using a lot of AWS services. And partly is because those core services were so serverless friendly, right? So we talked about SQS, S3, SNS as those, but there's really a whole ecosystem of other services all surrounding AWS Lambda that really make it easy and nice to build a serverless application, right? It has all these different components that you need there. So because those core services were serverless friendly, we saw a lot of these early stacks being AWS heavy. Also, it worked really well with infrastructure as code. Serverless was very heavy on infrastructure as code early, and most of the early tooling around serverless was built on top of CloudFormation. So whether that's serverless framework or SAM or CDK, all these had CloudFormation at the root. And because of that, there's just that slight preference for AWS services where you could provision those more easily through CloudFormation. Additionally, there's this built-in easy IAM integration where your Lambda function has a role associated with it. It's going to get some credentials when it's spun up. You can use those credentials without having to go retrieve them from somewhere else. Reduces latency. It also just is an easier security story, right? Those credentials are time limited and hopefully scoped down to just what they need. So it works very easily on that level. And maybe most importantly is just the reliability of AWS services, right? They do a great job making very reliable services. So because of these reasons, most of the time when I saw early serverless stacks, they're very, very AWS heavy. My rules for picking services, 4 years ago or so, is I always said, use AWS serverless services when you can. Use that as much as possible. If you need to, you can add non-AWS serverless services when you need them. If you really, really have to, you can use AWS non-serverless services when you must. And then finally, I just told people, hey, if it's not AWS and it's not serverless, you should really avoid it in almost all cases, because I think it's just not going to fit well with your serverless architecture. So that was true. We did see some early cracks in that rule of it being mostly AWS, right? So some early non-AWS services that were in there were Auth0 for authentication. You had Snowflake if you're doing analytics, OLAP workloads. and more in your runtime Algolia for search, right? So those were the early things. But now over the last couple of years, the floodgates have opened. We're seeing a lot of examples of non-AWS serverless services, right? So on the database side, PlanetScale, TIDB, Neon. Caching, we have Momento, we have Upstash. Front end wise, we have Vercel and Netlify. So a lot of options in this space recently. So then I was thinking, when do developers mix in non-AWS services to their stack? What does that look like? What sort of distinguishes those services? I would say it's usually around two things. One is user experience, right? Sometimes, third-party services that are focused on a specific area can have a better user experience. And the example here being Auth0. Auth0 or Cognito from AWS, I think are similar products in a lot of ways. The biggest difference being Auth0 had really good docs, a lot of good just learner material, and they had a good user interface where it was easier to sort of find your users, interact with them that way. So very much prioritize user experience. I think also in the front-end deployment world, Vercel and Netlify, we've seen a lot of usage there, right? Where it's just very easy, low configuration to have preview deployments, to have a pipeline for your front end where it's very easy to test this sort of thing. And it makes me think of a quote from Joseph Ruscio, who said, AWS is better at plumbing than at painting, right? AWS is amazing at building foundational infrastructure and making sure it's very reliable, it's up, it works, and all that sort of thing. But some of that higher level stuff, the painting, the beauty, the delight on top of that is a little harder, and that's where sometimes you see, third-party tools come in. Another one I think that's interesting lately is PlanetScale, right? Which is a database. Database, I don't think of like a user experience forward type of thing. But you're seeing interesting things from them around branching for migrations, around insights for queries, what's happening, and around automated updates. So that user experience is one way you see sort of non-AWS services in serverless applications. I think the other way is just if you see, some places are doing multi-tenancy better than AWS, and this is where Snowflake came in, right? When Snowflake came out, the major AWS competitor was Redshift. Redshift was more single tenant. You're spinning up specific servers somewhere and managing those in a particular way, where Snowflake uses S3 under the hood. It has, ephemeral compute on top of that, and just a much better sort of serverless experience there. A similar thing with Algolia for search as compared to Elasticsearch or OpenSearch on AWS. And then, we'll see from folks today from TIDB and Momento, similar type things where they're doing these multi-tenant services that are really nice. So I think those are the two areas where you might be choosing non-AWS services. So I've tweaked my rules a little bit for picking services now, right? I still prefer AWS serverless services. I think that's going to be your best bet in most cases, as long as it's truly serverless services, right? But I'm not as afraid to mix in these third-party serverless services when we want to, when it fits. But I think you still want to avoid non-AWS, non-serverless services. Not gonna fit as well in your architecture. All right, last section. Patterns for successful serverless teams, because I get a lot of questions on just like, how can I be successful with serverless? And a lot of times people want specific tactical things like, which deployment tool should I use, which service or architecture or different things I can use. And I think a variety of those can work. I've worked with small teams and large teams, lots of different tooling setups, lots of different setups. I think those specific tactical things matter less than just the principles of sort of how you set up your team, how you think about experimentation and development there. So I like to think about principles for successful serverless teams. I think the biggest one is you really need to take time to learn the platform, right? AWS has a ton of services. AWS is awesome. It's got so much, but it can definitely be overwhelming to try and, you know, figure out all these different services and how you can do them. And you don't have to do all these right away. You can sort of iteratively add these into your stacks as you need to, but do take the time to level up, right? And I think this is an analyst from Gartner, I believe, Lydia. She's talking about how just a lot of cloud adoption projects are failing because people don't know how to use AWS or use the cloud well. So take the time to level up your team and figure out how to use this stuff well. On that same note, I would say empower your team, right? So not only should you be learning the services and things like that, but try to centralize as much and give as much autonomy to a team as you can, right? You don't want to split up into operations teams over here, development teams over here, or have it go through a DBA, a gatekeeper, or sometimes an operational gatekeeper. I think the more autonomy a team can have and responsibility for owning their actual service, the more successful they're going to be. They're going to be able to move a lot faster, learn a lot faster as well. Make sure you sharpen your tools, right? I don't think the specifics of which tool you pick matters that much, but make sure you're using it well. And especially there are some areas where you want to set up for success, right? You can do, some teams like to do local development. Some teams like to do cloud first development. I've seen both of them work and both can work quite well. But the big thing is just make sure you have that set up so it's not a fight every time you're trying to test something, whether it's locally, whether it's in the cloud. Just make sure you're able to do that quickly and make your team go faster. Likewise, same thing with deployment tooling. You can use a lot of different deployment tools. Make sure you understand how it works and how you can reliably and safely get from your machine to a test environment, to a production environment, and back if you need to. And finally, monitoring, right? We're building distributed systems now. We can't log onto our server and pull off the logs and figure out what happens and tweak something live. You need to understand what these services are going to expose to you in terms of metrics, logs, just failure modes in general, how you're going to find out when they're not working, how you fix that. So you need to understand your monitoring stack and get familiar. And you can use, I like the AWS native stuff. I love CloudWatch and CloudWatch logs and all that. You can use serverless specific ones like Lumigo or Baseline or whatever, but think about monitoring and make sure you're set up to understand what's happening in your application. Of course, you have to automate everything and make sure that this can get through very quickly. This goes back to that version control idea, and especially applying that to your infrastructure too, because infrastructure is part of your application now. It's not just your compute is your application and that your infrastructure is static, but SQS queues, dead letter queues, everything around that, S3 buckets, whatever it is, that's part of your application. You need to make sure that's all automated as well. And then finally, choose your partners carefully, right? I was just talking about the rise of non-AWS services, and there's a lot of potential there. There are a lot of new infrastructure startups coming out every day, which are exciting, but also just make sure you're choosing a partner that is reliable, that you can trust. Don't understand what stage of company you're at and what sort of risk you can take there, because AWS is a great partner. They've proven that time and time again around that. I love AWS. But also these non-AWS services, if they have a track record of excellence, or if the people involved, have a track record of excellence, just make sure you're vetting that and understand what you're choosing there. So those are the big patterns I see for successful serverless teams. Again, the key goal here is you want to enable experimentation, rapid development. You want to be able to iterate quickly and move quickly. That's how you're going to learn faster. That's how you're going to make your customers happier. That's how you're going to have the most successful product you can have. All right, so wrapping up here. We talked about serverless now and then, right? I've loved being a part of this community for the last 9 years. I think there's so much. I'm loving seeing all these people come here on a Saturday morning, and I love the excitement in serverless. just thinking back to, the road to serverless, how Heroku sort of set us up for that, and how the 12-factor app, set up some of those initial principles, I thought was very interesting. Thinking about multi-tenancy and that as the key to serverless, and especially in choosing your AWS or choosing the services you're using. And then finally, some of those trends I'm seeing around the rise of non-AWS services and just what are those patterns for successful serverless teams. So that's all I have. Thank you for having me. I really appreciate it. I'll be around for questions and looking forward to the talks today. Thank you.
Thank you, Alex. So great serverless history and the great current landscape of serverless. So great. で、Ask the Speaker ブースにアレックスさんがちょっといてくれるので、で、聞きたいことある人はぜひ聞いてください。で、一応通訳してくれる人もいるんで、ちょっと英語できないっていう方は通訳してもらってください。